It's another shot. Um, Still working through some technical glitches as I try to get you a decent video to help you through some of these things. I'm going to be using this particular app called Screencastify where you can actually see what I'm writing on my screen. You'll notice, however, that I don't have a lot of space to write in, and so it'll be limited. I'll have to go through and erase it, and these videos have to be limited to 15 minutes also. So we'll just kind of see how it goes. What I would ask you to do is please read your book. Something that scares students quite a bit, but especially in a pre-AP level class like this geometry class, you would be shocked at how much you can learn by simply spending 10 to 15 minutes reading the book and then coming back to this video to get a little bit of extra information. I've already put 3 assignments out there. Each one has limited questions. I'm trying to limit it to around 10 questions so that you can just learn the basics of what you need to. But please go ahead and try to use that book to supplement as much as we can. All right, let's begin the lesson today from 10-4 on perimeter and area of similar figures. I'll leave you to review your notes from 10-1, 10-2, and 10-3 as we get going. This assignment is now not due until Tuesday. All right, Theorem 10-7 states a couple of things that we need to know. If you've got a scale factor between figures, and the figures are already known to be similar, of A over B, well, basically what that means is your perimeter is also going to have that same scale factor, whereas your area is going to have the scale factor squared over squared. In practice, it's actually very easy to figure out. If, like the example in the book, you have a couple of figures with a scale factor of 6 to 9, that means that the actual scale factor, when simplified, is 2/3. But when you go to perimeter, your same perimeter will be 2/3. So if you had a perimeter of one shape of 15, the other shape would be 2/3 of that, or 10. When it comes to area, however, the scale factor changes to 4 over 9. And so it would be 60/9 for area. Slight difference when you're dealing with area on that. Hopefully that makes it fairly easy. That is, again, Theorem 10-7 on how perimeter and area works with scale factor. It makes sense, though. If everything about similar figures maintains consistency in scale, then it would make sense that perimeter and area would do the same. The only difference being area has to be squared for that particular use. All right, also in this section, finding the area using similar figures. We've got two figures. One, let me switch back. We've got two different pentagons. One has well, hold on, let me see. The smaller pentagon has a side of 4, and the larger pentagon, which we're told is similar, has a side of 10. And the area is 27.5 centimeters squared. So knowing that, we're trying to figure out what is the area of the larger pentagon. Okay, well, my A over my B is 4 over 10 or 2 over 5. But we have to square both of those because we're talking about area. And so it's going to be 4 over 25 when discussing the areas. So we've got to use this scale factor of 4 over 25 equal to the area of the smaller. Notice that 4 goes with 27.5. Sorry, my 5 there's a little bit messed up. We'll just deal with it. Over the unknown area of the larger shape, which goes with the 25. You can notice right here that all you have to do to finish solving it is to go ahead and cross multiply and get 4a equals 25 times 27.5, which is 687.5, and then divide both sides by 4, which leaves you with approximately 172 centimeters squared. So that's how you'll do problems dealing with area or perimeter in the midst of the scale factor. Always use your scale factor. Simplify the scale factor down as much as possible. Then determine whether your scale factor is perimeter, stays the same, or area, both need to be squared top and bottom. And then you can use that scale factor to determine your other answers. All right, finished erasing there. Let's look at a third problem. This one is more of a word problem where it says, during the summer, a group of high school students cultivated a plot of city land and harvested 13 bushels of vegetables that they donated to a food pantry. Okay, so we've got 13 bushels in a word problem. Let's write it down. That's supposed to be bushels, but again, I'm writing with a stylus. It's a little bit tough to do there. Now, when we're talking about plots of land, those 13 bushels, wouldn't that be area? So area is going to be that. So we're talking about an a squared over a b squared situation here. The new plot is 2.5 times the original plot. All right, so 2.5 times gives us the ratio of a over b. It's equal to 2.5 over 1. Okay, so that's an easy way to do it. The problem is we're dealing with area. So I have to square both, and I get 6.25 still over 1. Do you see how the adjustment has to be squared when we're dealing with area? So basically what you end up having to do is multiplying 6.25 times your 13 since it's over 1, and that will lead you to approximately 81 bushels in this word problem. Okay, so that was problem 3 in your book. I'll allow you to review that if you need to. I'm trying to do everything in the book and go through each lesson fully in the book because your Math Excel will have problems drawn straight from the book. And we're just going to make things easy on ourselves during this kind of weird virtual teaching time by doing everything consistently. Luckily, we've already been doing a lot with the book throughout the year. All right, there is a fourth problem that I want to look at real quickly. The fourth problem says we've got two triangles. Go ahead and draw them since they're triangles here. You can see that the two triangles are different sizes, but one has an area of 50. The other has an area of 98. Now, those are centimeters squared, but we'll deal with it like that. All right. So it says if these two triangles are similar, what does the scale factor have to be? Well, it doesn't really matter whether you go small to large, 50 over 98, or large to small. Either one will be appropriate. The thing is, we have to understand that this is an a squared over a b squared situation when dealing with area. So our a squared over our b squared is equal to 50 over 98 or 98 over 50, which means that the first thing we should do is probably simplify everything. What is 50 over 98 simplified? Well, it's pretty easy to see that they're both divisible by 2. It's really 25 over 49. Whoops, got to erase that, wrote it backwards. Which means that we can then take square roots of both to get back to our original scale factor of a over b. So we're going to show ourselves taking square roots of both and getting a scale factor of 5/7. All right, guys, we'll stop there. This particular section is not too hard. I hope we don't have any problems, but good luck with it. If you need help on tutoring, remember that we're going to have those tutoring times Monday, Tuesday, and Thursday from 1 to 2. But you may need to text me or email me in advance to let me know, and I'll send you a Zoom link that we can join up and get together on some of the problems that you may be struggling with. If not, work on those problems on your own, get a good pace, get ahead, and I think you'll find that it's not a bad way to learn.